All right, we're going to prove that n factorial is greater than n squared for every integer n greater than or equal to 4. Okay, so we're going to do a proof by principle of mathematical induction. So we're going to do the base step. So we're going to look at p of 4 because that's where we're starting, right? So 4 factorial is equal to 4 times 3 times 2 times 1, which is 24, right? All right. And then, of course, 4 squared is equal to 16. And of course, 4 factorial is going to be bigger than 4 squared, right? So that works. I'm going to go ahead and move on to the induction step because it's pretty clear that 5 is going to work as well. So let's do the induction step. Suppose P of k is true. Thus, we have k factorial, right? K factorial is bigger than k squared. So now we're going to consider k plus 1 factorial. So by definition, k plus 1 factorial is equal to k plus 1 times k factorial. And we know this is going to be bigger than, so k factorial, so it's going to be bigger than k plus 1 times k squared, because we know k factorial, by assumption, is bigger than k squared, which this is equal to k cubed plus k squared. Now, let's go ahead and consider what we want, right? So let's consider k plus 1 squared. That's going to be k squared plus 2k plus 1. Now we have to show that k cubed plus k squared is bigger than this, right? Well, I can see for pretty much any positive integer, k cubed is going to be bigger than k squared, right? But for um, k bigger than or equal to 4, we know k cubed is always bigger than k squared, right? And this is more interesting. For k bigger than or equal to 4, we know, so k squared is going to be bigger than or equal to 4k, right? If we multiply both sides by k, right? And we know 4k, so we need this to be bigger than 2k plus 1. But we know 4k is going to be bigger than 2k plus 1 for k bigger than or equal to 4. Because if you were to plug in 4 here, this is 16. And if you were to plug in 4 in here, that would be 2 times 4, which is 8, plus 1, which is 9. And 16 is definitely bigger than 9. And that would go for 5 and so on, right? So we know k cubed is bigger than k squared, and we know k squared is bigger than, definitely bigger than or equal to 4k, and we know 4k is definitely bigger than 2k plus 1. So let's go ahead and look at this, right? So we have k plus 1 factorial. We know that's bigger than, right? We sort of derived it here. K plus 1 factorial is bigger than k cubed plus k squared. And we know k cubed is bigger than k squared. So we know this is bigger than k squared plus, and we know k squared is going to be bigger than 2k plus 1, right? And of course, k squared plus 2k plus 1 is k plus 1 squared. So we were able to show that k plus 1 factorial is bigger than k plus 1 squared given, right? Given the fact that k factorial is bigger than k squared. And of course, we had to use the assumption that k was bigger than or equal to 4 to get these inequalities, right? And then we were able to prove it. Therefore, by the principle of mathematical induction, for every n bigger than or equal to 4, we know n factorial is bigger than n squared. And that is our proof.